Today we will start the lecture from F.Y.B.Sc. paper second, that is organic chemistry. This is the last point from chapter first. Fundamentals of organic chemistry. And today's topic is aromaticity. Before starting this aromaticity, we discuss about the types of organic compounds. There are two types of organic compounds. Aliphatic and another one is aromatic compound. Aliphatic means fatty compounds and aromatic compounds means the word is coming from aroma. Aroma is nothing but this compound having specific smell. Now when we consider the example of aliphatic compounds, alkane, alkene and alkyne. So we consider the example from alkane. The first member, methane, methylene and acetylene. And the best member or the example of this aromatic compound is benzene. Now we move towards the characteristic of the aromatic compound, or it is called as aromatic character. Aromatic character. These compounds are highly unsaturated. And generally the carbon atom is sp2 hybridized. Second thing is that it having low heat of hydrogenation. As well as low heat of combustion. And hence these compounds having the unusual stability. Means this compound having the more stability as compared to aliphatic compounds. And third one is that these compounds are cyclic planar with 5, 6 or 7 membered ring. These are the some aromatic character of the aromatic compounds. Now practically these compounds are identified with the help of sooty flame test. Suppose aromatic compound, it burn on spatula, it gives sooty flame, and this compound gives a sooty flame is due to the high ratio 1:1 ratio of or high ratio of carbon and hydrogen as compared to aliphatic compound. And aliphatic compound does not show the sooty flame after burn because the ratio is not 1:1. This compound having some criteria to find the whether this compound is aromatic or non-aromatic theoretically. So criteria for aromaticity or criteria for aromatic compound. Now we will discuss one by one. First of all, the first criteria of this aromaticity is compound should be cyclic planar, because generally the carbon atom are sp2 hybridized from the aromatic compound, and you know very well about this. sp2 hybridized carbon atom having the geometry trigonal planar. That's why the first criteria of this aromaticity is this compound should be cyclic and planar. Second thing is that this compound having the delocalization of pi electrons, sometimes lone pair, but this is related to heterocyclic compound or ionic compound. And third one, this compound should follow the Huckel rule. That is 4n plus 2. This is the criteria for the aromaticity. That is, this compound should be cyclic planar, and there must be a delocalization of pi electrons, and third one, it must obey the Huckel rule, that is 4m plus 2. Now we will discuss some examples which follow this criteria, and we can judge this compound whether these compound are aromatic or non-aromatic. So First, before starting this, we will see the classification of aromatic compound. Classification of aromatic compound. Now there are two types of aromatic compound. Is benzenoid and non-benzenoid. Benzenoid compound means those compound having the basic benzene ring. Like the best example is benzene, naphthalene, and in case of non-benzenoid compounds, again there are two types. Non-benzenoid compound is nothing but those compound still it is aromatic, but the basic structure is not from benzene ring, and hence the non-benzenoid compound is again classified into homocyclic and heterocyclic. Homocyclic and heterocyclic. In case of homocyclic, the example is that cyclo, hepta, trinyl, cation, and heterocyclic compound. Example is pyridine, as well as pyrrole. Means in both cases there are no basic structure is benzene, and hence it is called as non-benzenoid, but it is aromatic compound. Now today we will apply this criteria of the aromaticity on these compounds. First of all, we take the example benzene. Now, from the criteria, first point is it should be cyclic. Yes, this benzene ring is cyclic in nature, and all carbon atom are sp2 hybridized. So this is a planar. Second one, there are delocalization of pi electrons. Means we delocalize the pi bond through resonance. And third point is that from the criteria is Huckel rule. That is 4n plus 2 equals to a number of pi electrons. That is 4n plus 2 equals to, there are 3 pi bonds and hence 6 pi electrons, and we solve this equation. 6 minus 2 is 4, n equals to 1, and 1 is nothing but this compound having the one ring, as well as this one always integer number. If this n value is 0.5 or 1.5, then this compound doesn't follow the Huckel rule, and hence it is non-aromatic. Okay, so this benzene compound follow all these criteria, and hence this benzene is aromatic in nature. Now we take some more examples from the aromatic compound from the benzonoid classification. Now we take the example of naphthalene. Again, this is cyclic in nature. All carbon atoms are sp2, so it is planar. There are delocalization of pi electrons. What happened here? This is shifted here, this is shifted here, this is shifted here, and we obtain the new resonating structure. So this compound having the delocalization of pi electron. And third one, it follows Huckel rule. 4n plus 2 equals to how many pi bonds? There are 5 pi bonds. So total 10 electrons. So 4n equals to 8 and n equals to 2. Means this compound having 2 rings, as well as this number is integer. This compound is integer, and hence this compound is aromatic. Okay, we will consider one example from non-aromatic. Suppose you take cyclobutadiene. We take the example of cyclobutadiene. Now again we apply this criteria of the aromaticity, that is, it is cyclic, planar, there are delocalization of pi electron, okay, and last one, Huckel rule. There are 2 pi bonds and the number of electrons are 4. So 4n equals to 2, n equals to 1/2 and n equals to 0.5. And hence this is not a integer number, it is fractional number, and hence this compound is non-aromatic. This compound is non-aromatic. Means you should know it must follow all these criteria for whether this compound is aromatic or non-aromatic. Now we will take the example from non-benzonated organic compound. You know very well about this. Non-benzonated aromatic compound having 2 types, that is homocyclic and heterocyclic. First of all, we will take the example from homocyclic benzonaide, aromatic compound, that is cycloheptatrionyl cation, trinyl cation. Now again we will apply these three criteria. That is, it is cyclic. Yes, it is cyclic. It is planar. Yes, it is planar, because all carbon atom is sp2 hybridized. Then there are delocalization of pi electrons. Delocalization of pi electrons. Okay, and last one, there are whether it is obey the Hooke's rule or not. Now here 3 pi bonds mean there are 6 pi electrons, and when we complete this calculation, it is 1, means there are 1 ring is present, and all these criteria are followed by this compound, and hence this compound is aromatic in nature. Now we will take the example from non-benzonide heterocyclic compound. Non-benzonide heterocyclic compound. Heterocyclic means there are one heteroatom other than carbon. Now suppose you consider this example, this is benzene, but when we put here one carbon replaced by nitrogen, then this is called as heterocyclic compound, and the name of this compound is pyridine. Now we will apply this criteria on this compound and find out whether this compound is aromatic or non-aromatic. Now here this compound is cyclic as well as planar. Second, there are delocalization of pi electrons. Actually this pyridine is like a benzene, only difference is that one carbon is replaced by nitrogen, so there are delocalization of pi electrons, and we obtain the another structure here. Okay, mean there are delocalization of pi electron. And third one, it follow the Hooke's rule, that is 4n plus 2 equals to 6, because there are 3 pi bonds and hence 6 pi electrons. Okay, so n equals to 1, means there are one ring and this number is integer. This number is integer. Now we take last example. That is pyrrole. Now again we apply these 3 points. First of all, it is cyclic, it is planar, because all carbon atoms are sp2 hybridized, and another one is that this compound having the delocalization of pi electron, but one difference is that here lone pair are involved in the delocalization. So here double bond, and it having the lone pair, and it carry positive charge. So there are delocalization of pi electron. And third one, suppose we apply the Huckel rule. Here difference is that there are this lone pair is converted into pi bond and this pi bond is converted into lone pair. So total pi electrons are 6. So 4n plus 2 equal to 6 and n equals to 1. And hence this compound is aromatic. So today we discuss about the aromaticity and classification as well as the criteria of aromaticity, and also we take some examples from aromatic compound and some from non-aromatic compound. Thank you.